Time travel, humanity's endless journey beyond the present. Few ideas in science capture the human imagination as powerfully as time travel. The ability to move backward into the past or forward into the future has fascinated philosophers, scientists, and storytellers for centuries. From classic literature to modern physics, time travel sits at the curious intersection of imagination and scientific possibility. While it may still belong largely to the realm of theory, the concept has inspired serious scientific inquiry and continues to challenge our understanding of the universe. It also encourages us to question the very nature of reality and our place within it. Long before the language of modern physics existed, people wondered whether time could be manipulated. Ancient myths and legends occasionally hinted at strange journeys through time. In some stories, a person would fall asleep for what seemed like hours, only to awaken centuries later. These tales reflected an intuitive curiosity: if space could be traveled, why not time? Such narratives reveal how deeply rooted the idea of time travel is in human culture and imagination. The scientific discussion of time travel truly began in the early 20th century with the revolutionary work of Albert Einstein. His theory of relativity transformed the way scientists understood time itself. According to Einstein, time is not a fixed and universal clock ticking identically everywhere in the universe. Instead, time is part of a four-dimensional structure known as space-time, which combines the three dimensions of space with the dimension of time. This idea fundamentally changed how we perceive motion, gravity, and the structure of the cosmos. One of the most fascinating consequences of relativity is that time does not pass at the same rate for everyone. When an object moves extremely fast, close to the speed of light, time slows down for that object relative to someone standing still. This effect, known as time dilation, has been confirmed by experiments using highly precise atomic clocks and fast-moving particles. Astronauts aboard spacecraft, for example, experience time slightly more slowly than people on Earth, although the difference is tiny. These findings demonstrate that time is not absolute but relative. In principle, this means that traveling into the future is not only possible but already happening in small ways. If a spacecraft could travel at speeds approaching the speed of light for a long journey, the astronauts aboard it might experience only a few years passing while decades pass on Earth. From the traveler's perspective, they would effectively have jumped into the future. Such possibilities continue to inspire both scientists and science fiction writers alike. Traveling into the past, however, is a far more complicated matter. Physics does not easily allow backward movement through time. Some theoretical solutions to Einstein's equations suggest that certain exotic structures, such as wormholes, might allow a shortcut between 2 points in space and time. A wormhole can be imagined as a tunnel connecting distant parts of the universe. If one end of such a tunnel experienced time differently from the other, it might theoretically allow a form of time travel. This idea, while fascinating, remains unproven. Yet these ideas remain highly speculative. Wormholes, if they exist at all, would likely require forms of matter with unusual properties, sometimes called exotic matter, to remain stable. No clear evidence has yet shown that such matter exists in the required quantities. Moreover, time travel to the past raises famous logical puzzles, such as the grandfather paradox. What would happen if a time traveler altered events that were necessary for their own existence? Such questions continue to challenge both physicists and philosophers. Because of these paradoxes, some physicists suspect that the laws of nature might prevent backward time travel entirely. Others suggest that if it were possible, the universe might operate according to self-consistent rules in which paradoxical events simply cannot occur. These debates highlight how much we still have to learn about the fundamental laws governing time. Beyond science, time travel continues to thrive as a cultural idea. It has been a central theme in literature, film, and television for more than a century. Stories about time travel allow writers to explore history, imagine distant futures, and ask philosophical questions about fate, free will, and the nature of reality itself. They also reflect humanity's desire to escape limitations and explore endless possibilities. Time travel reminds us of something profound about human curiosity. Even though we remain bound to the present moment, our minds constantly move through time, remembering the past and imagining the future. Science may one day reveal new ways of understanding time, but for now, time travel remains both a scientific puzzle and a powerful symbol of humanity's desire to explore the unknown.